Alright, hello everyone. What we're going to focus on in this video is simplifying algebraic expression. Alright? But before we can look at how we simplify algebraic expression, there are two terms that we need to familiarize ourselves with, which is what we call like terms and unlike terms. Alright? So we're going to look at what are like terms and what are unlike terms. So let's say that we have some terms, and the terms that we have here are, let's say we have x, right? We have 2x, and we have 3x. Now these terms are like terms. Why? Because they have the same variable, which is x. Not only that, but the degree of the power is 1. So each x term here is raised to the power of 1. So therefore, they are like terms, right? Let's say you are given y minus a half y. You are given 0.5y. Then these are also examples of like terms. Again, y, they have the same variable, which is y. And the degree of the power of the variable is the same, which is 1. So therefore, they are like terms. Let's look at some more examples. Let's say you are given 3a squared, right, as a term. And you are also given minus 4a squared as another term. You are also given, say, 1 over 4a squared. Then these are also examples of like term. They have the same variable, which is a, and the degree of the variable is 2. All of these terms. So once it satisfies that condition, then they are like terms. Alright? So let's look at one final example. So if you are given something like z to the third power, comma, minus 2z to the third power, then you have another term, let's say a fraction, and this is 1/5 z to the third power. Then this is an example of like terms again. The variable is z, the degree of the power is the same, which is 3. So therefore, these are like terms. So now what we're going to do is to look at unlike terms, right? And I'm going to write these in green. So, what are unlike terms? Now, let's say you have some terms and you're given x. And then you're given y. And then you're given x squared, right? Now, this is an example of unlike terms. Note that the variables are different. Alright? So the variables are different. So therefore they are unlike terms. Let's say that you are given x for a second example. Then you are given x squared, and then you are also given x to the third power. Alright? Now this example would be an example of unlike terms. Why? They are unlike terms because they are different terms. Well, you may ask, but all of these are x. Yes, even though the variables are x, look at the power. The power are different. So the first term here, x, is the same thing as x raised to the first power. And then this is x squared. And then this is x to the third. So therefore, because the powers or the exponent are not the same, then they are unlike terms. Alright? So if you see something like this, which is y, Then you have an x term which is y squared. Then you have an x term which is y to the third power. Then you have an x term which is 3y to the fourth power. Then this is an example of unlike terms. So despite the variable is y, note the degree of the power are different, so they are unlike terms, right? So if you see something like this, which is 3p, then you have an x term like 2a, then you have an x term like 0.6b, then you have an x term which is a fraction, let's say 1 over 4q, then this is an example of unlike terms. Now, why is it important to understand what are like terms compared to what are unlike terms? We can only combine like terms to give us one term, right? So we can only combine like terms. So we cannot combine unlike terms, right? And we're going to look at some example to demonstrate what I'm saying much better. Alright. So let's look at the first example. Let's say you are given x, right? You are given x, for example 1. You are given x plus y plus, say, x plus y. And you are asked to simplify this algebraic expression. Note here, we have two set of variables dealing with x and y. So first, we would need to group the like terms, right? So here, we could group the x's. So if we group the like terms, then what we would write here is x plus y, right? And then now what we will do to simplify this is to group the like terms. So this x term, x by itself means 1x. So we have 1x plus another x, that is going to give us 2x's, right? Plus, here we have 1y plus another y, that's going to give us 2y's. And this expression is in its simplest form, y. Here we have one term which is an x term, and we have another term which is a y term. So they are unlike terms. They cannot be combined any further. So we leave it as such. Alright? Example 2 now. Let's say we have another example which we have 3x plus 4y plus 7x, right? And they are asked to simplify this expression. Then again, first thing you will do is to group the like terms. So we're going to rearrange this to write the like terms beside each other. So we're going to put our 3x. Then we have a plus 7x down here. We're going to write it here. So it's plus 7x. And then we put back our plus 4y. Then we combine the like terms. So if we combine the like terms, we have 3x's plus 7x's. So that is going to give us 10x's plus our 4x. At this stage, it cannot be combined any further. Reason being, they are unlike terms. So we cannot combine them to give us one term. So we leave our answer as is. But let's see example 3, you are given x squared plus 3x squared, right, minus 7x squared, right? So that's what you have been given, and you're asked to combine this. Note the variable here is x squared, so all of these terms are like terms. So what we could do is to combine them to give us one term. So x squared, and remember that this is 1x squared, so 1x squared plus 3x squared, that's going to give us 4x squared, minus our 7x squared out here. Now we have 4x squared minus 7x squared, and that is going to give us a negative 3x squared. So in this case, you know there, I can combine these terms to give me one term, and the reason being that all three terms here are like terms, so they can be combined to give me a single term.